we go. So the activity that we're going to be working on is going to be taking keyboard input. You guys have seen examples of at least this part of it before. And what that's going to turn into is that's going to turn into this, where we're writing a program that's going to request the type of triangle as well as the base and one side length of the triangle. We need that in order to determine which type it actually is and what area, and that way we can output the information back to the user. We're going to use a new category of tool that we haven't used so far, called a switch statement. What that's going to do is that's going to control what we actually get back from this. So there's a bunch of kind of nice utility that comes out of this. So using a switch statement and one or more functions to complete the analysis. In order to do that, we need to know what the analysis looks like. So the process that we're going to use is we're going to include ultimately all of these different types of triangles, and we're going to include some logic and validation for this. So we need to know what the sides and what the height is so that we can understand what it is that we're actually working with. We can verify it. We can do some calculations. One of these is the law of cosines. So c squared is a squared plus b squared minus 2ab cosine of c. And for a triangle that has sides ABC, the half perimeter for Heron's formula is half of A, B, and C, the sum of the three. So half the perimeter. The area can then be found by a formula using the half perimeter value. So that's a lot of different individual calculations. We also have to include how we're doing each of these. So we have to write each of these functions individually, and then we're going to transfer what we've learned about writing custom functions to do stuff. We're going to transfer that over to just like the tone function that we had to do the other day. We're going to transfer that to libraries because you need it for actually creating the libraries. So we have a bunch of pieces of this puzzle to come back to. Now, what we're going to need is, I'm actually going to need a new example here. So again, scariest thing in the known universe, a blank programming sketch. Prepare yourselves for the horror. All right. So how do we start with this and get to all of that? Well, there's a few key kind of pieces to the puzzle here. And this is something that we really want to pay attention to. There's a lot that we need. So I'm going to start getting you guys in the habit of setting up functions out ahead of when we need to use them. So instead of starting the functions at the very end, what we're going to do is we're going to use make sure I've got both up here. Let's see. There we go. We're going to use both, and we've got a few that we're going to need to do. So we're going to leave ourselves some room ahead of setup. So we're going to bring this down. a little bit. All right. We need our comments telling us what it is that we're doing. So this is a program that calculates the area and validates the type of triangle the user specifies. All right. So that's what it is at a very, very, very high level that we're doing. So we're going to need some things. We're going to need to do some calculations. So we need to include the math library. We need to include the math library. So you guys' favorite thing in life, hashtagging all the things, include math.h, and this needs to be in our braces. We're in our little bird beaks there. We're also going to need a couple of other things. Whenever we're using cosines or sines and we're doing trig, in the comments, let me know one of the things that we inevitably have to use, one of the math constants that you know. Which one do you think that's going to be? If you were to take a gamble, what math constant do you think we're going to need?
Like the pi, just pi.
Yeah, pi. Why do you need pi? Because reasons. So we're going to here do another hashtag, only we're going to do a define, and this is going to be pi, and we're going to define it as 3.14159 because I don't remember enough of the rest. These guys don't need the semicolons at the end. They're one of the only ones that doesn't because reasons. So now we need to know what's the program going to do. We need to know it needs to ask for user input of it needs to ask for user input of 1, 2, or 3 for triangle type, and then it requests the length of the side and the height, or it'll request the length of 2 sides, and then it will figure out the rest. So there's a number of ways to kind of approach the context. So it's actually going to do, rather than the height, because somebody may not know that, we'll say the length of 2 sides. That's the way that we will write it. That's going to both simplify and also sort of complicate things because reasons. So from this, it calculates the length of side 3. Outputs triangle type. Actually, this one we can do an even cooler thing. We can skip the defining. We can actually ask for just the length of two sides. So let's simplify it down. Rather than doing verification and all the other stuff that would inevitably be part of this, let's simplify it down. Just ask the user for the length of two sides. From that, it's going to calculate the length of side 3 and output the triangle type. Okay. Let's simplify it down a little bit, make it a little more digestible. We're going to need to define some variables. For multiple calculations. That means that we're going to define them as public variables so that lots of different functions can use them. This becomes very, very important for when we go to do libraries, which is kind of the next major step. This is a logical step, even if it doesn't make sense. This is the next logical step because we need to have some global variables that it's going to be able to access for all the different functions that we're going to use. Then we're going to do the setup. So if we're going to be doing input, we know we're going to need some variables. We can come back and kind of define variables and start adding because there's going to be a bunch. So we're going to leave some space up here to be able to do that. We know there's going to be a couple things. What's one of the first things that we need to do in the setup for sure if we're going to be taking in user data? See how awake you guys are.
Open the serial port.
Yeah. So we need to open the serial port. $9,600. There we go. Serial.begin 9600. Okay. The fancier version of what we were just looking at is something that we can start including because we've talked at least a little bit about operators. While not serial, this while not serial, this waits while the serial port's opening. So this says chill out until you start getting data in once the serial port is opened. And that's really the key for how to make this work smoothly when we're trying to do input. So we also need to get the user input here in the setup because we don't want to be looping and asking the user, okay, put in two sides, okay, put in two sides, okay, put in two sides. We really want to just ask them one time what two sides are in the triangle so that we're not doing all the rest of it. So this part, so we need to be able to store user input. in the chat, tell me some of the things that we're going to need in this. What do you guys think? What kind of variables are we going to need? So we're probably going to need both integers and float type variables for this. What do you guys think? We're going to need to know something so that we can store the input variables as a minimum. So what might we use for that? We also don't know if somebody's going to pull a vote for turnip and give us the length of a side is 48.6745, right? We could store them as integers, but then we lose that data. It would be rounded or truncated, so we lose that data, and we generally don't want to just lose data, not if we don't have to. So what would we do? For that, you probably want to float because that means a floating point decimal. So this allows us to store more of that kind of information. It will also store integers just as a 1.000 or whatever. What this does is this enables us to do a few different things. So the variables to store the user input, we can actually define, since it's going to be a bunch of floats that we're going to be taking in as data. We can do a few things. So we can include one for base, one for side A, side B, side C. So then that allows us to capture all of the stuff that we're going to need, because we need to know something about base. We need a side A, B, and C. All of the triangles are going to have a side A, B, and C. Even isosceles triangles, you're going to have to effectively cut in half. So then you're going to have a base value, any other type of triangle, an isosceles is going to have a cut, and you're going to have a base, and it's going to be part of one of the sides. So you're going to need to do something with that basically the whole time. So there's a couple different options there, but this is a simple way to handle this because you can define multiple variables of the same type using the comma. So we haven't done a lot of this, but this is going to be a program that's going to be a little bit bigger. So a little space efficiency is going to be a good idea. So we're still going to need some other stuff up here and lots of variables up here. But this is stuff that we're going to need immediately inside that user call to action, that input type. So there's another couple that we're going to need as some intermediate steps. So let's start looking at what it's going to be to lay them out. So we're going to need some more variables. But instead of try and explain to you why we need all the variables, let's start working on putting together the formulas and things so that you can see what stuff we're going to need variables for, because that's really the best way to actually go about it. So we're going to need a couple more things. We're going to start with asking the user for input, right? We're going to do that with serial print lines, and we're probably going to have a few of them because the first one needs to be something like, well, we can ask them about the triangle type. So it could be the case that the user is going to think that they have dimensions for an isosceles triangle, and it's actually a scalene, and they just happen to be wrong. Um, we have we have a lot of instances in recorded history where people have thought they had the right information and turned out to not quite be the case, right? So we need to be mindful of that in our coding. So we'll go ahead and ask them what triangle type they think it is. Um, the following numbers to identify the triangle type. So some kind of request to please enter the following numbers of the triangle type. And now we come to the next step here. So this is another serial dot print line. Here we need one for, this will be for equilateral. We want to make sure that we want to make sure that we're closing stuff off with semicolons, because if we don't, everything in the universe explodes. Some of those things. Okay, so we've got serial print line. We're going to need another one. Quotes 2 is going to be isosceles. Spelling at this point in the semester is not a simple matter. It's a real Greek spelling. Isosceles is correct there. Until we fact check it and find out that I'm defective today. All right. Serial.print line. And we have the last one, which is 3 scalene. Some of you probably didn't remember the word scalene until today. That's okay. Worse things have happened. Now there is kind of a trick. Remember that we had kind of some issues with the input data where it would be a little hard to get the timing right to be able to get the board to accept a serial input. We can kind of use a trick to do that, and that looks like this. While serial dot available is comparable to 0. So this is a little while loop that we're going to run. We haven't done a lot of these. That's okay. We're going to store this to a variable, but we need the name of a variable because we've just asked them to identify the type. So now we need to read the user input. So this needs a variable. We'll do simply try type for triangle type. So we'll have to go up here and redefine it in this group. So try type is serial dot. This is what I was showing you on that slide where you can use what's called a parse integer, and then we close the while print line, and we do an output of that try type so that we can see what they've input, and this will verify. This is that verify process.
Do we need to specify the data type for try type?
Yes, we do. And that's why I said we're going to need a whole bunch more stuff up here, because if we just leave it there, we're going to encounter errors. So we need try type. So we're going to need for sure try type. And this needs to be an integer. So try type. We're also going to do a calculation later. So we can include not just try type, but we can say a try type when we need to calculate. Try type calc as the second integer that we're going to need. So what this will do is this will allow, really this is not actually running inside a while loop. This is just a command saying, while this condition is happening, do nothing, then assign try type to whatever it parses from the serial input, then print it back out for the user to do a validation step. So there's a couple more things that we need to do here, and we need to ask user for the length of side one. We're going to internally call it side one because I don't have a better idea for what else to call it as. So we have to do a serial print line, serial.println, and we need to say the length, please enter the length of one side, or something to that effect. So then we have another read function, and we're going to keep using this idea over and over again of while the serial available, and we do want to close that with a semicolon, otherwise we're going to get compiler errors. Same thing with this one. It's one of the easiest things to miss always, so it needs to be a habit. So we're going to come back to this, and this helps us to not have as much chaos. But now what we're going to do is we're going to incorporate a timeout for the while. So this is going to set up an actual while loop, which is going to be kind of a new thing for us today. That's okay. There is a thing called a serial dot set timeout. And this is if the user falls asleep, goes to the bathroom, gets up to get a drink and kicks their keyboard halfway across the room and yanks the cable out of their computer, or whatever stuff happens in the meantime. The serial port watches for a certain period of time for this and then times out. So this is in milliseconds, something like 15-second timeout. So 15,000 milliseconds is usually a sufficient amount of time. Then it sets a timer for, hey, if I don't have input within this time, step out of this while loop. If we don't put a timeout in a while loop, what will happen is widespread death and destruction, basically. You'll lock up the computer in an infinite loop, and you can't get out of it. Yeah, there was a kid that was, I think, a senior in high school when I was a sophomore, and he knew that I was a little bit sharper than the dullest tool in the shed. So he asked me if I could write a program for him for his calculator, because he also had the fancy pants TI-89, and so it was him and me and were the only ones in the school that had one. But he knew that there was a possibility of doing that, and I think he was looking for an answer. I decided to be a smart aleck and wrote a program that asked him a couple of questions, and then no matter what he did, it would kick it into a never-ending while loop. And so whatever series of inputs he would give it, it didn't matter. It would kick him into an infinite while loop. And then, of course, he couldn't actually use the calculator because you can't just hit escape. You can't just turn it off. You have to actually enter a correct command to break the loop. Yeah, anyway, he was surprised that I could do that to his calculator, and decided that maybe cheating wasn't worthwhile. So with great power comes great responsibility, I read somewhere once. So you set a timeout for a while loop, because if you actually have a while loop using these curly braces, if you don't and somebody sits there and doesn't do anything, you cause something to happen. You want to break out of that loop so that it's not just stuck and consuming resources, etc. So there's a madness to this. Or there's a method to this, rather. There we go, side A. Side A is going to be defined by, side A is going to be defined by the same as this up here. So serial parse integer. And then we're going to close this while loop. So then we've asked the user for input. So that's another piece to the puzzle here. We're going to need, so we've got the length of side 1. We've got the length of side 2, and I'm trying to remember. I'm trying to remember if, I think Heron's formula is general, if I remember correctly. I think Heron's formula is general. So if that's the case, and I'm pretty sure it is, I think we can simplify it down to using Heron's formula. So I think we're going to start with that, as I seem to recall that one works for most cases. So it's not a perfect general case solution, but it's a start. So we have a couple ways that we can approach it. We're going to need basically this whole thing again. Ask user for the length of side 2. So this is going to be the length of the second side. Same deal, same timeout. This is going to be side B. So we've still got side A, side B. We've got all of those defined. And I think for trouble with Heron's formula, though, is it needs to have all 3 sides A, B, and C. So we might have to do the length of side 3, because fundamentally, you need a third piece of information, whether it's the base, whether it's the triangle type, or whether it's the length of that side, which is what we're referring to as the base. You got to have that piece of information because you're limited by the number of degrees of freedom. So that's another concept that you guys will learn elsewhere, but it bears relevance here on this example. So we need side 3, also known as the base. Ask user for the length of side 3. All right, so we're still doing the set timeout. We're going to do, instead of second, third side, same timeout. All right, so we've got the 3 sides. Then we've got, all right, so we've got the data in. So we're actually going to have to change this. The length of 3 sides. From this, it calculates the area and outputs triangle type. Input of the triangle type. So we want this to reflect the keys for what we're doing. There's a couple other components that we're going to need there, but we're still only using the variables side A, B, and C and tri-type, which are defined for use here inside of the setup, and that's okay. So we can't run 100% of everything all inside of here because we are going to need our main operation. So we need to perform the main operation with a switch case. So this is something that is kind of like having the if else if else logic structure, except it's a lot cleaner way to do it. Assuming I have a suspicion that that Camaro was not within the boundaries of the speed limits just then. Have my suspicions. So we're performing the main operation with a switch case. This is, you can think of it like switches on an operating board or something like that. Channels on a soundboard, if you guys have ever been around a soundboard. If not, one day, maybe thank the sound guy in your church. He'll probably fall out of his chair in surprise, because those guys are like completely invisible to all of the rest of the population. Switch case is fairly straightforward. We start out by calling out switch, and then we're going to use try type as the variable. What is the main operation? We're going to comment some more on that so that we understand what it is that we're actually doing. So we set up our switch case. What that means is we need individual cases, and it's looking for the word case specifically. So case 1 colon, not semicolon, but colon. This is going to be the easy one to think of. So this is equilateral. So case 1, what happens? Everything that happens is going to go in this case. Instead of curly braces, we have a different kind of bread to contain our sandwich here. And we end with what's called a break. So it shows you the connection here between case and break. So everything that happens between that case and the break is what's executed. We have a case 2 because we have the isosceles. Isosceles, and this is yeah. Sound guys speak truth. Only a sound guy would know, because only a sound guy would know, and that's why. Just saying. Person who has literally like never even seen, never shakes hands, but suddenly everybody remembers the instant somebody has a mic problem that there's a sound guy. When things run well, no such thing. It's a real issue. All right. So we are, get back here. So case 2, then we have our break. Then we have case 3 colon. This is for our scaling. So the math is different for each of these, and we know that. And we break case 3. At the end of the cases, instead of doing like an if, else, we need a last category as the catch-all for anything that doesn't fit the above 3 categories. So the reason to store case 1, 2, and 3, the reason to store this data type as an integer, and the reason to take in data from the user as an integer and use the parse integer function is to prevent errors if they were to type ONE or TWO or something like that. We want to make sure that we get integers in, because otherwise our switch cases don't work correctly. So the last one, always written, is called the default case. The default case is whatever happens between here and the break.
I have a quick question.
Yeah.
Is the 1, 2, and 3, is that the assigned value to try type, or is that just like it's always 1, 2, and 3?
So cases are almost always going to be there's a couple different options. This is where I'm going to pull up the language reference, because I think let's see, under documentation.
I was just wondering if, because if we had like a different kind of case, if try type was like 43 or something.
So most of them, switch and case statements, I'm going to share this here in just a second so that you guys can see it. There are some flexibilities. Integers and numbers are the easiest to use because that's just the way that it is. So you can use labels. It's taking in a variable. It could be strings. It could be some other things. You could have, you could technically use a switch statement if you only had two cases. You know, like if we were developing a switch statement for the weather in Phoenix, right? Talk about like the weather person. The most superfluous job on planet Earth is the weather person in Phoenix, right? Like seriously. I cannot think of a more easily replaceable human being than that person, because you could literally replace them with a switch statement in code, like switch statement, sunny, case, no, cloudy today, output, right? Print out cloudy today. Default would be the only other case that you would need, and it would be sunny and hot, and print out it's hot today. That's it. You're done. You've now replaced the weather person with a switch case, right? So you can use other variables, but the switch case works better for certain things than trying to do logic gates with if statements. It's a thing that controls the flow of information from one part of the program to another one, but it does it in a way like controlled gate valves that you intentionally turn on and off, rather than using check valves and hoping that you got them all in the right order. Does that make sense? Because a check
Yeah,
valve, like,
I was just
keeps it
wondering
going
if
back
it
the other
was
way.
because I didn't know if the labels, like how it says there, I didn't know if the
Mhm.
labels were just numbered in this
So
language, or if it was just if like where the arguments were, if it was underneath the cases, or if it was
yeah,
like embedded inside, or if it was.
so the variable is really, 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 you can use Boolean if you're just specifying two cases, but it's almost always got to be a variation of integer. You can use byte, character, integer, long as your choices. Integer is the simplest, and that's why we're using that one. Byte isn't necessary for this, but the idea is you want to make sure that the integers are easy to use, because if you use case 1 and you use 1 as your input for the variable, then you input the value for the variable. 1 is going to correspond to case 1, 2 is going to correspond to case 2, anything else is going to correspond to the default case, right? So that's what it's trying to do. And there's more sophisticated gating and things that you can do with the flow of information. I'm trying to give you the simple use case for a switch case statement, because I want you guys to be able to get a handle on how this works. A lot of times these are going to be a better mechanism to control the flow of information in your code than just logic gating with if, else if, because the difference between an if and an else if is not always as clear, because if you have to say, well, if it's in the range of this thing, for doing like a value comparison, for instance, you could use a logic gate to do some testing. If the value is between A and B, then do whatever is in case, then set the variable to case 1. You could do some things like that. So switch cases are not good for like doing the value determination, but it's good for what does the program do under this defined set of conditions as input by the variable integer, whatever that is. So the cases are often going to be numbers, so having them as different labels can be helpful, but you can put the label in the comment next to case 1, 2, 3, 4, 5, etc. The nice thing about a case statement is you could have literally 100 different cases, and that's totally okay. And it's much more easily able to sort through, do this for case 95 versus do that for case 76, than if you make a mistake somewhere in the logic gating to where it runs through and skips over the logical comparison that you want. If you had too many if else ifs and you did them in the wrong order or something, because it kind of tries to run through them sequentially, but that gets farther into the weeds really than we've had to go so far. So we're going to keep pressing on this, but you'll see how this starts to come together. So what we need to put into case 1 for the thing that's actually being done is the important part. So we need, in this case, if it is in fact equilateral, and we're assuming that the user is not just trying to vote turnip, this could start with side C equal.
Oh, by the way, we're still on the doc screen.
Yeah, let me switch.
Thank
This
you,
is where
by the way.
the next generation of software is going to be hopefully able to keep up with some of these kinds of examples. Live window is fine and what I prefer to do, except I have to have a multi-monitor setup to make that work really well. And at the moment, I don't have my multi-monitor available, so it's too many things to have on one screen without having at least one of the infinity loops. All right, so you could start out with something like side C equals side A, but we already know, based on what the user has said, they think it's an equilateral, so they've given us sides. we could do logical test and say, if this, then that, if not, then break, and print out an error message, or print out an error message and then break is actually the sequence you would have to do there. But we're going to assume that side C and side A are the same. There are obviously some quick logical tests you could do for that. So now we need a calculation variable, because we need to do side B, because we'll use side B for the base, is equal to, or side B divided by 2. We need to do side B divided by 2, but we don't need to keep this variable because this is just a temporary value. So we can actually call it temp equals side B over 2, right? Half the base times the height is where we're going with this, because the height is another one that we're going to need. So height equals, so we're going to have to go back up and define these. I just want to think through real quick what we're going to need, so that then we can go back up and define our variables here, because we don't really want to define variables inside the switch statement. That's I mean, we're using variables, but we don't want to make a habit of defining new variables inside of switch cases, because you may have to use the same variables in multiple of the cases. So you want them defined outside of the switch case, so they're not local to the switch case. They need to be global to the switch case, so all the different cases can make use of them, so that you're not typing the same thing over and over and over and over again, defining the variables in case 1 and case 2 and case 3 and so on. Because especially if you have 100 cases, you don't want to be copying and pasting code over and over and over and over and over and over again. But these are going to be used so much, these kinds of temp and height and some of the other ones, that this is probably stuff that we want to think about putting even outside of the setup, so that the whole program can use them. And height always means height. Temp always means temporary storage place for a variable that we're going to need in calculation. So these are things that we want to be keeping in mind. There's a really cool function in the math group that we can use here. No, don't do the things there. I was trying to get another space like that. Okay. What this is going to do is this is going to take side A and side C. So side A and side C, and it's going to calculate the height. It is a very useful function, but there's a couple things inside of the math function set that turn out to be quite useful. We're going to need C, because again, we're going to need a variable to be able to actually do something with this, because we need to know the a squared plus b squared equals c squared. So C is the Pythagorean from height and temp. So we need temp, we need height, we need C, all as things that we're going to access. And then we need something to store that information in, another variable, yet again, which is going to be area. And this is going to be another cool function that we can use, triangle area. This one is not super duper confusing, but it's going to be side B, and height. So base and the height to calculate the area. Okay, fairly straightforward. This allows for what we need to get all of these pieces put together. So what do each of these do so that we have comments when we go back to this to understand what on earth is going on? So this stores half the base for calculation. This calculates height based on two sides. And assuming again that the equilateral is legitimate, this calculates C from A and B, and this calculates area from height and base. Okay, so we know what these are now. All right, so we got case one. Only the whole rest of the program to fill out. Before we get too carried away, we want to go back and define these because we need that information to be available. So at least here within setup, as a minimum, we're going to need these. So we're going to do some floating point variables for this. Because we're going to be working through, so this is area, this is height, this is C, this is temp. Those are the ones that we were just using. We're also going to need a couple other versions of this for some of the cases that are coming. So we can say height R, and we're going to have another version of C as well. So we're going to need all of these guys. Okay. Then for some of it, we're going to need to have law of cosines, but we'll come back to that when we're ready for it. So case two. In order to look at an isosceles, this one is reasonably straightforward. Not quite so much as the first case, but it's pretty close. So we're going to set up for an isosceles. This is where there's the opportunity for the equilateral, this isn't necessary. For the for this case, we're really going to need to be robust. Some people might enter the two sides that are the same as A and C. Some people might enter the same sides as A and B. Some people might enter the same sides as B and C. So there's multiple combinations of which side should be which one. In order to be robust, we have to account for all of those different kinds of inputs, because we don't know how they're going to put the same sides together. We could go back up and try to control that based on their input, but maybe they still enter it in the wrong order. And the two lengths that are the same size are B and C, but you just don't know. You told them to do A and C, but they did B and C instead, or whatever, right? There's a lot of ways for people to use an interface incorrectly. So equilateral was simple. The isosceles is brutally simple if you know the two cases are the same. So we're still going to use this part of it, the height. We're still going to use the Pythagorean. We're still going to use the area. So that part is going to be the same. The question is, how do we handle the madness here? So there's a couple pieces to the puzzle that we want to keep in mind. What we're trying to do is we're trying to say, okay, and this is one of the instances where you may want to incorporate some logic in order to say, hey, is this going to work the way that I think it is? Yes or no, and why? We can do an if and then say if both of these values are comparable, then do this. Else if both of these variables are the same, then do this. Else do this. And you can do logic structures inside of these, and that's okay. There's a couple things that we could do. We could ask the user for further input, so you can do that within a case structure. Um, there's a lot of different ways that you could handle it. You could even use logic and then an internal switch case based on their answer. Probably don't want to do that because reasons. So it's not too terrible to handle on the back end the conditional comparison, and say if, and we're trying to compare side A. Side A is comparable to side B underscore B. So case one, if this, so we can set this up for the first case where side A and side B are the same. So then if side A and side B are the same, then side C is going to be, so we're going to use side A and we're going to use side B. Let's see. We can do it with either A or B in one of them and then C. So if A and B are the same, you need to have the two different values. If you have the two same values, this doesn't work. So you need to make sure that your conditional and your height calculation are a different pairing because reasons. So when this one, when we set up the else if, we're going to do something a little bit different. So else if, so this is a case where we need to combine the two, and then we need this to close the else. So we need this to close the else. So we're going to work out the logic for the first one. Then we're going to change the A, B's, and C's until we're all content. Otherwise, you have to make a brute force reassignment of variables. That could be incorrect. You could get the wrong area. You get the wrong output. Somebody does the calculation. They get the wrong amount of materials or the wrong type of material. They get it the wrong size. Somebody ends up hurt, you end up fired. Bad stuff happens. So maybe don't do that. Height is triangle height calc, side A, side C, etc. C is Pythagorean, HT and temp. So this stays the same, the height and the temp. The temp, what does that calculation look like? Temp is equal to, this is going to be side C, because it's, again, we want not the side that's in the comparison, because this is saying if A and B are the same, then side C has to be the base. Thing that makes sense. You just have to think through what the logic is. So it's side C over 2. All right. Side C over 2 is equal to temp. Height, compare side A, side C. C is going to be height and temp in the calculation. Area is going to be the base. In this case, the base is actually going to be side C, because we want it to be not the same as the other two. So this is the same case. We need it to be side C. So basically what we do, else if is, let's see, do we need a third case? A and B, A and C, C and B. Yeah, we do. We do. So side B, let's do side A is comparable to side C. So now it's A and C. In this, we're going to do the same calculation. We're going to do the same calculation, but we're going to take the side that's not in the comparison. So side B, side A, so side C converts to side B for all of these. So if side A is comparable to side C, now what if side B, this is the else case, so this is side B comparable to side C. So this is the else case. We have the same thing, except we're now going to do the one that's not in the comparison, which is side A. So side A becomes the base. And this one, I want to double check that this is correct. This is fine because A and B are, or A and C are the equal length sides. So it doesn't matter which one you use, it's going to give you the same result. Down here, we have to change this to C and side A because reasons. Goes back to don't ask questions you don't want the answer to. So side A, you want the one in all of the other formulas that is not in the comparator that it's running under. Okay, so quick check, grand clarity scale. Where do you guys fall? 1 being dry dirt, 10 being holy water. Where do you guys fall on this case 2 so far? Okay, pretty high overall. Good. All right, this should begin to start making a little bit of sense as we continue to roll through it. And I don't know if you guys will survive the process of getting all the way through the whole thing today or not. So we have to have the 3 cases for isosceles so that we can cover all the different bases because reasons. All right. Then we break. Each of these really should have their own break. So I'm going to cut this and paste it in. Each of these really should have their own break because when we're done, we step out of the case. Step out of the switch case when done is really what this does. So we need all of that. Step out of the switch case when done. All right. So each of those has its own break. Okay. That is an acceptable way to do the order because the break is going to be the last thing that happens. Once we've done the calculation, we break out of case 2. Otherwise, it's going to run down here and look for more stuff to do before case 3 starts. So break is stepping out of the case for each of those. Okay, scaling. This is where all 3 are different sizes and we need to figure out what's going on. For these, there's another piece of information that we're going to need. Does anyone know what that is?
Is it an and statement?
Close. We're not going to need an and statement yet. We will. start looking at some comparisons, especially when we get to do some stuff in MATLAB and we're working a lot more with arrays. That's why I haven't really hammered on arrays yet. I'm trying to hammer on the way that other stuff works in coding so that when we go to do operations on arrays, we can focus on array math and what that is, but already understand what to expect from some of these kinds of functions. For the scaling, there's one more piece of information that you need, because if I give you 3 sides, do you have enough information to actually tell me the sum total of the information or not? We can set up the default pretty readily. I'll let you guys think about it for a second. The default case, in this case, is going to be doing what all good software does, right? Yelling at the user. Invalid selection, make better life choices. Break. Okay, so we've got our default done, but we got to think a little bit about this third case. So if the user has only given us 2 side lengths, do we have enough to determine what we need or not? In order to use the example for the law of cosines, we need the angle. So we need something about 2 of the sides, and we need the angle C. If we know the 3 sides, we can reverse that expression, and we can determine what the angle is. That just becomes it's a little bit of a hassle, but it's not yeah, it's, you have to know something about the angles. So we know the Pythagorean theorem. We could check whether or not the lengths of the 3 sides were actually whether or not the lengths of the 3 sides were actually a scalene triangle or not, whether or not it made a valid triangle. We could determine that. It's a little bit hard to have it be an invalid triangle, because even if one of the sides is 1, you've got quite a bit of angle to work with. But if you were to put something like 10, 1, and 6 or something like that, yeah, okay, that may be a problem, because you're physically not going to be able to reach, so it's not going to be a valid triangle. So it does have to be a valid triangle. In this case, you're going to have to make an assumption that they've given you some correct values. If not, trying to prove the logic otherwise for this specific instance is going to be challenging. So if we have the third length, we need to figure out how we can get back to the area based on, or get back to the third length based on what we know. So what piece of information can we, or what approach could we use? And I'm going to remind myself what's in the math library. Um, because there are a lot of functions. We can do square roots. You can do, let's see. Yeah, there's a lot more math functions that that can be used. Oh no, those functions that I'm referring to, I think I think those are ones that we actually have to generate. If I'm remembering correctly. I think those are not, yeah, those are not built-ins. So that was some of the functions that we're going to have to incorporate. So let's start pulling some of those in, because there's yeah, there's a lot of ways to do it. But let's start with based on, yeah, because triangle height calc is Pythagorean. We're actually going to have to define those. Triangle area, yeah. I think even Pythagorean is not. Yeah, Pythagorean is not. It's a simple, straightforward one to create, but we are going to have to create those. Because right now, if we hover over this for information, it'll say, yeah, I recognize that you're using it in two places, but man, I have no idea what this thing is or what these variables are. Same thing with height calc. Whereas serial print line, we know what a serial print line is, and we know what the actual loop is. Okay. Yeah, this one's going to be a little bit more of a challenge. So this is something that we might sort of run out of time for today. We're going to need plenty of variables for multiple calculations, and we're going to need to start defining characteristics. So start defining the functions used below. The height calc is one of the first ones that we're going to need, and that one needs to be based on this. That needs to not be an integer, that needs to be a float. So we want this to output a float back to us. So instead of a void, we're going to use a float. Triangle height calc. And that's going to take in these variables. So float, float. And for the purposes of simplicity, we're going to call them float A and float B. Then, because this is a function, we need to have our open, close curly braces, and we're going to need this. We're going to need these variables to be able to output. So they also need to be floating points. We do all the calculations, all the variables in floating point so that we don't lose any of the data integrity. So float, you need both HT. You can use, again, the temp calculation for base divided by 2. And one of the math functions that's actually here, which is the square root. So height is equal to, they call it SQRT in the MATLAB, or the function here. Square root is also SQRT in MATLAB, if I'm remembering correctly. So this is the square root of, and then we also have to use the power. So lots of square rooting and powering, minus the second piece. So this is a to the second power. So a squared, this is how you have to write it. In MATLAB, you can at least use a caret and square things directly. We'll deal with some of those things later. You could technically do a times a in here, but when you start dealing with higher order things, it's hard to keep track of number of times. Using the power function, make sure you get the correct exponent, which is a better habit to be in. So again, really trying to focus on giving you guys good habits to do the things that you need. So this is the square root of a squared minus 0.25, so 1/4 of, and then power this temp, which is half the base, and 2, so temp squared. Because we're squaring this, we've got all the right number of opening and closing parentheses here. We got to check these always. Yeah, we have those. Okay, so this calculates the height for us, and now it will recognize that this is a thing that's defined. So we're going to go ahead and save this as, since I haven't done that yet, which is terrifying. Let's see, sketches. Triangle calc switch tells me the things I need to know about this. Okay. We'll get to some more complicated things related to functions later. We're not going to deal with that right now. This is also a lot of stuff. So I think this program is physically a little bit bigger than what we can reasonably tackle today, because we won't get all the way to functioning. I think we'll have to pick this up next week, because I'm sure you guys are probably very nearing brain meltage. On a scale of 1 to 10, 10 meaning my brains are literally leaking down through my shoes, as I speak, and one being, nope, I can do this all day long. How bad is the brain meltage going on at the moment? I suspect we're going to average somewhere around like a 7 to 8. Yeah, it's almost like I've done this before. All right, I think this is a reasonable pause point. We're not going to make tremendous major headway in the last few minutes here. We will save this as is and come back to the redefinition because this is a much larger scale program than anything that we've attempted so far. So this is bigger, this is broader scale. We're only about 115 lines so far, but this is going to be a much bigger, much gnarlier program overall because we've still got some more functions to bring in. But it's multiple levels of things that we're trying to learn all at once, and we'll start learning how to start feeding these additional functions into custom libraries next week. So we'll finish this up and see how to start doing this so that instead of having to write functions like this, maybe we want to be able to use the triangle height calculator all the time. We could put this into a custom library and then always refer back to it so long as we included it, just like up here we're including math, so that we can use square root and power in our calculations. So I think we're going to pause there for today. Any major questions?